We're looking at the Ariane 44P launcher due to liftoff for flight V083 with Nstar B in a little over 28 minutes from now. The camera has taken us into the new Mission Control Center in the Jupiter 2 building, in service tonight for only the second time. Ladies and gentlemen, hello and welcome to the Guyana Space Center in Kourou. Commentary for this event will be provided in English by Bart Eilertsen and Simon Hayes, and in French by our colleagues Michel Fergit and André Payet. We have a generous 2-hour window for this flight, opening at 6:54 GMT, that's 3:54 local time here in French Guiana, and equivalent times are showing on your screen now. This broadcast is going out live to 5 sites in France, Washington, D.C. and Palo Alto in the USA, and Tokyo, Japan. We have, of course, a special word of welcome for all of those associated with the Nstar program at Space Systems Loral, NTT, and NTT Docomo. And straight off board, a quick update, please, on launcher satellite and weather status.
All 3 elements are green, Simon, and ready to go.
And this is confirmed on the status panel on your screen now. Explanation of the panel in a moment or two. But first, some launcher and payload facts and figures.
Well, tonight we shall be able to observe the relatively rapid liftoff phase, which is typical of the 44P version of the Ariane 4 vehicle. The first stage, which was filled with its 230 tons of liquid propellants yesterday, will be burning UH-25 and nitrogen tetroxide at a rate of 1 ton per second during its 3.5 minutes powered thrust phase. For the first minute of flight, the 4 solid propellant strap-on boosters will be responsible for providing nearly half of the total thrust of the vehicle. The second stage uses the same type of self-igniting so-called hypergolic propellants as the first stage, but now using only 1 Viking engine specially adapted to high-altitude flight conditions. The third and final stage uses a highly efficient propellant mix of liquid hydrogen and liquid oxygen. Fed by a turbopump spinning at 60,000 RPM, the single engine provides approximately half of the total velocity increment necessary to reach desired orbit. Due to the volatile nature of the supercool cryogenic propellants, the fueling of the third stage is conducted only hours before the launch through 2 fueling arms, with a detachable plate ensuring the interface for liquid and pneumatic lines going to and from the stage.
And we shall see the arms open just 5 seconds before ignition at T0.
In this split image, the hydrogen arm is on your right and the oxygen to the left. Now, all of the foregoing elements are being commanded and guided by the electronics boxes, the brain of the launcher housed in the equipment bay lodged on the top of the third stage.
The fairing protects the very big payload on the pad and during the atmospheric flight phase. It will then be split open by a pyrotechnic cord system and jettisoned after 4.5 minutes flight. And the satellite passenger Nstar B tucked away on the payload adapter inside the fairing, 50 meters above the launch table. And cue for the Space Systems Loral film.
今日はですね、一応昨日の作業は順調に進みまして。ですけれども、すみません、ちょっとお願いがあるんですよ。今日使いに行った時にね、牛乳をうっかり買うのを忘れてしまって。
Expanding communications across an island country and within important shipping lanes, linking people to people throughout Japan. This is the mission of Nstar. Nstar is a 2-satellite system designed and built by Space Systems Loral to dramatically enhance fixed and mobile domestic communications in Japan. Built for Nippon Telegraph and Telephone Corporation and its subsidiary company, NTT Docomo, the 2 Nstar satellites will take over the geostationary orbits of the aging CS3 communication satellites.
In addition to replacing the 2 payload capability in the existing CS3 program, that is C-band and KU shaped beam services, Nstar adds 3 additional services for a total of 5 payloads, which will support NTT and its communication mission in Japan. The Nstar satellite is important to NTT and NTT Docomo for the expansion of services in Japan. NTT Docomo is a subsidiary of NTT and provides mobile communication services both terrestrially and for maritime service.
NTT and NTT Docomo challenged Space Systems Loral to build a satellite system that carries 5 separate and interrelated communications payloads that operate simultaneously on 4 frequency bands. The S-band payload provides terrestrial and maritime mobile communications service to Japan and its coastal waters. The Ka-band multi-beam payload provides satellite switch time division multiple access communications for the main Japanese islands and Okinawa. The Ka-band shaped beam payload provides 5 channels, each 100 megahertz wide, operating as a conventional turnaround repeater. The C-band payload provides 6 channels, each 72 megahertz wide. And the Ku-band payload provides 8 54 megahertz channels, each using a high-power TWTA as its final amplifier. Together, these payloads provide enhanced telephone, fax, television, and mobile communications for business and personal use in Japan. To ensure the high performance and long life of the Nstar satellites, Space Systems Loral has taken a bold step with this program. The Nstar program is completely turnkey. The satellites are being delivered on orbit to the customers. The Nstar satellites have life expectancies of over 10 years each. They will provide the people of Japan with a rich array of communication services well into the next century. As one of the world's premier commercial producers of communications and weather satellites, Space Systems Loral is dedicated to putting satellites to work in space that are both reliable and affordable. Space Systems Loral has become the leader in providing 3-axis stabilized satellites. And Space Systems Loral has consistently produced the highest power spacecraft in the communications satellites industry. Nstar is joining a proud Space Systems Loral tradition. With 165 satellites and over 500 years of on-orbit experience, Space Systems Loral delivers.
Back in Jupiter, now meet some of the Nstar personalities in mission control.
On your left, you have Dr. Samejima, the executive manager of NTT Technical Labs. And here we see the VIPs, our Japanese customers tonight.
The Guyana Space Center is particularly well located, just north of the equator, for both sun-synchronous polar orbit and eastward geostationary transfer orbit launches, as for Nstar B on this occasion. The ocean drop zone is also a major advantage.
The third stage of the Ariane vehicle will separate Nstar in its desired attitude and into a geostationary transfer orbit, which has its highest point at 36,000 kilometers from the Earth and its lowest point, called the perigee, at approximately 200 kilometers up. From that orbit, the Nstar spacecraft will have to fire its apogee engine to reach its final geostationary orbit, and these firings are being done at the apogee. In order to determine its correct attitude for these firings, the spacecraft will use its solar and Earth sensors for a 2-hour calibration period into its flight. The geometrical conditions necessary for this triangulation, as it is what gives rise to tonight's launch window, which is between 6 hours 54 and 8 hours 54 universal time. In order to get into its final orbit, the Nstar spacecraft will be doing 2 major burns, both of approximately 1 hour's duration to get into geostationary orbit. And during those 2 burns, it will also reduce the inclination of the transfer orbit, which is 7 degrees, down to the 0 degrees required to be in the equatorial plane.
And some more personalities in the command and coordination structure for flight V083. First of all, Bruno Gérard, Arianespace Mission Director for flight V083. Jim Harvey, Satellite Mission Director for Space Systems Loral. Francis Pellicer, Arianespace Launch Site Operations Manager, or the COL. He's in the Launch Control Center 1 kilometer from the pad. And the DDO, Mark Huber, Range Operations Manager here in Mission Control. And as promised, coming up now, an explanation of the status panel.
Well, the status panel is the synthesis of the readiness status of all elements involved in tonight's launch. From the blockhouse, the Launch Site Operations Manager reports on the status of the ground installations, as well as on the correct execution of the launcher countdown operations. Our customer tonight, Space Systems Loral, will be ready to go if its spacecraft and its post-launch ground control network are both functioning correctly. The meteorological station uses radar, balloons and satellite imagery from the European Meteosat spacecraft to ensure that wind, visibility and cloud conditions are within acceptable limits.
Launch base support covers logistic services such as power supply, lighting, transport and fire brigade functions in particular. And then a wide range of safety systems and facilities serving just about every aspect of directly and indirectly launch-related activities, the most important being flight safety. And finally, communications.
They are divided into 3 sections. We have the telemetry reception stations along the flight path, which ensure reception of launcher functional parameters throughout its powered and ballistic flight phases. Then there is the tracking network, which uses ground radars to precisely monitor the launch vehicle's flight path. Finally, the telecom network assures data and voice communications between the launch base and the downrange station network, as well as to the customer. All of this is summarized in the launch authorization status light. Green for go, red if one of the elements is not ready for launch.
This is the second Ariane launch in 1996 as we move into another very busy year. A word perhaps at this juncture on PAS 3R and Meosat 1, launched on January 12th, Bode.
They're both doing very well, Simon. Now we shall have a look at the launcher campaign that preceded tonight's flight.
The launcher campaign for flight V083, for which we're using a 4 solid propellant booster Ariane 44P, required 26 working days. For each campaign, the first 2 weeks are used to assemble the 3 stages and the vehicle equipment bay in the preparation zone dock. At the same time, the launcher for the upcoming flight is out on the pad, while another unassembled launcher is crossing the ocean or already ashore in Guyana. The Ariane we're seeing in these pictures is the 5th example of the 44P version to be flown, and the 55th Ariane 4. So how many people are involved in assembly operations, Bode?
About 120.
And what about the complete launcher campaign, including the support services?
About 400. What you're seeing here is the vehicle equipment bay being hoisted on top of the launcher.
The launcher is then rolled out to the forward zone 2 weeks before launch day D. The cryogenic fueling arms are closed onto the 3rd stage, and the gantry is brought up to shroud the complete launcher. The 4 boosters are strapped onto the 1st stage, and the launcher is ready to receive its payload.
You may have noticed the flat top configuration of the launcher in the rollout sequence.
Back in real time at T0 minus 30 minutes and 40 seconds. The plume you may have seen at the top of the launcher indicates that the third stage, liquid oxygen and hydrogen fueling, is nearing completion after 3.5 hours. The weather report just after we came on the air was good, and we shall have final met data in about 3 minutes from now. Next on your screen, some film of the Nstar B satellite campaign leading up to mating with the launcher 6 days back.
The Nstar B arrived here on the 16th of November on an Antonov 124 cargo plane. After being hoisted out of the aircraft and onto its flatbed truck, it was then taken straight to the S-1B preparation area, where the spacecraft was put through its usual string of functional verification tests of its electrical and mechanical systems. What you're seeing here is it's being put on its vertical and horizontal working stand. Right here, we're doing a fit check with the flight adapter, which is being done early in the campaign to make sure that there are no snags in the mechanical fit between the two elements.
And there we have a very good view. It's a really big one, Lord.
Nstar is a very big spacecraft. It's probably in terms of volume, the one which fills out our fairing the most of all. As the tests in S1 were finished, the spacecraft was put into the CCU, the payload transport container, and taken out to the S3 area, which is very close to the launch pad, for what we call hazardous operations, which involve fueling the spacecraft with its propellants. Now, the reason why these people are walking around in these moon suits is because the propellants are both toxic and corrosive, so you need to be very careful with the handling of those elements. Afterwards, the spacecraft was put onto its adapter, this time for good, put into the fairing, and transported in that configuration out to the launch pad, hoisted up to the payload platform, and set down on the top of the launcher, which is what you see in the picture right there. And this happened about 4 days ago.
Nstar B will be setting off to join Nstar A, launched less than 6 months ago on Ariane flight V083 in about 11 minutes. We just saw Mesut Ciciga, the Ariane payload manager for this flight. The two spacecraft are strictly identical and will be located at orbit stations 4 degrees apart over New Guinea. This will take the number of Japanese commercial telecom satellites launched on Ariane to 9, plus 2 more in the order book, equals 11 or 75% of this particular market. We now have in camera Charles Bigot, chairman and CEO of Ariane Espace. He heads the 4-man command cell, which is there to take any major decision or participate in a decision during countdown.
Formed in 1980 as the first industrial and commercial space transportation company in the world, Ariane Space operates the Ariane launch system developed by the French space agency CNES on behalf of the European Space Agency ESA. Ariane Space demonstrates European scientific and technical capabilities. It has the backing of the space industry and banks of 13 countries. Ariane Space operates worldwide, with its European headquarters at Évry, just outside Paris in France, a subsidiary in Washington, D.C. in the United States, a branch office for the Asia-Pacific zone located in Tokyo in Japan, and a launch complex with a unique geographical position in Kourou, French Guiana, close to the equator. Ariane Space is engaged in a long-term production program with its European space industry partners. Carefully regulated manufacture of the Ariane launches is permanently aimed at optimized quality, costs, and completion dates. Some 12,000 highly qualified Europeans are engaged in this manufacturing activity. The success of this venture is largely due to the power and cohesion of the industrial partners involved. The principal contractors are Aerospatiale, SEP, MBB Erno of the DASA Group, BPD of the Fiat Group, Matra Marconi Space, CASA, British Aerospace, and Oerlikon Contraves. The various launcher sub-assemblies are built in Europe and taken by sea, air and land to the Kourou spaceport.
Well, during that clipboard, you've been listening into the final weather report. What have you to tell us?
Well, apparently we have practically a clear sky and no risk for any thunderstorm activity or other, so we're okay.
That is good news, and of course the rest of the status panel is set at green for go in less than 8 minutes. Launcher fueling is just about complete as we come to our last piece of film, shot less than 6 hours ago. At this point, the gantry is pulled back about 100 meters, leaving the launcher secured by the table clamps and cryogenic arms only.
Of course, this gantry has, until tonight, served as protection for the launch vehicle, served as a mechanical access to the various parts of it, and notably in order to put the solid strap-on boosters on, which is done at the pad. But as we're now moving into fueling operations, or we did, as a matter of fact, 3 hours ago, that tower needs to be moved away because we're fueling liquid hydrogen and liquid oxygen, and the gaseous forms of those are, as most people know, very explosive. This movable structure, weighing about 3,000 tons, was moved away about 5 hours ago now, and as you see, at night.
Well, we're really getting very close now. It looks calm, but you can feel the tension mounting even through the plate glass. All ground stations are on full alert. Their readiness is confirmed on the status panel.
À tous de DDO. Suite à un
Just like all the other systems here.
arrêté et la
In a few
séquence
moments,
synchronisée
at
ne sera pas
T0
entamée.
minus 6 minutes, we come to a radical change in the command situation when we enter the synchronized sequence at the end of this 14.5-hour countdown. And we have stopped, in fact, on T0 minus 6 because we have a red on the status panel for the
Spacecraft. Nstar B is showing a red.
À tous de DDO, que tous les moyens restent prêts pour le début de la séquence synchronisée dès le retour au vert.
So we've just had an announcement from the DDO saying that we shall pick up the count as soon as we clear the red on the spacecraft. Obviously, at this point in time, we here in the commentary box do not have any information concerning the reason for this red, but as soon as we have some news, we will pass it on to you. But what we can tell you is some idea of the procedures that have been initiated as soon as the red came up.
Well, of course, as far as the launcher and the downrange stations are concerned, they're still green. We're holding at minus 6 minutes, and we can go into start up from there as soon as the problem which is holding up Nstar is cleared.
And is there any change in the launcher situation? Are any procedures initiated?
As long as we have not gone into the 6 minutes, no, there are not.
Mm-hmm.
It's stable.
And of course, one point that we can make immediately is that we have a 2-hour launch window, so it is to be expected and certainly hoped that that provides us with a very adequate margin.
We have a very comfortable launch window at night, yeah.
Well, we shall be on the lookout for any information we can get on the situation, and obviously any hypothesis would be dangerous and even a waste of time. Looking around here in mission control, there is no sign of agitation or activity. In fact, we can learn nothing at all from watching the operational personnel here. Would the situation be similar in the launch control center, Bart?
Well, in this particular case, they are sitting around waiting as well.
We have, without knowing what the cause is, we've just had advice that we shall be probably on hold between 10 and 20 minutes. So the first thing that we will do now is to ask you to be patient while we endeavour to get some initial indication as to A, the cause, and B, what is going on. So, do you have something to tell us, Bud?
Yes, I mean, I've just been informed that they have a small doubt as to the configuration of the spacecraft. They will do a re-verification of the onboard, the uploading of the onboard program, and this will take approximately 10 minutes.
So, in fact, that is what they're doing now.
Indeed.
À 12 de DDO. Donc pour information, on devra avoir un nouvel H0 une dizaine de minutes après l'ouverture de fenêtre.
So we just had an announcement from the DDO that there is a strong likelihood of a restart in about 10 minutes from now, in which case we will recommence the count at 6 minutes in just the same way as a normal entry of the synchronized sequence. I think we'll perhaps wait until we do get a restart to explain the synchronized sequence, because it would be more appropriate to tell you how it functions while it is functioning. I think we just have some information coming up in a moment or two, and we'll pass it on as soon as it becomes available to us.
Of course, Simon, what one can say is that the center of activity right now is in the S1 building where the spacecraft ground station is located.
In camera now we have the head of the Guiana Space Center, Monsieur Mignon.
And as would be expected, we see that Jim Harvey is on the phone with his colleagues.
Indeed. Just to put viewers' minds at rest, I think you might explain, Bod, what the flame we saw just now at the foot of the launcher is. In fact, it's not at the foot of the launcher, it's further behind.
It's quite a ways behind, yes. It's
I think you should relieve people of their
it's
anguish.
it's a base in which they burn off liquid hydrogen, which comes back from the launcher, if you like. So it's not at the foot of the launcher.
No.
It looks spectacular, though.
Yes, well, the first time one sees it, it's at least intriguing. Premature liftoff. Ignition, anyway. And in fact, that the liquid hydrogen is part of the cryogenic third stage fueling system. Will this delay have any effect on the cryogenics of stage 3?
Anyway, it has an effect in the sense that the liquid oxygen and hydrogen is continually being vaporized
And topped up, therefore.
So there's a continuous process of that going on to make sure that we lift off with the correct amount of propellants in the tanks.
And a weight such as this, a hold such as this, does not have any particular effect on the temperature control?
Not at all, no.
No.
As a matter of fact, the brick-like appearance of the outside of the third stage stems from the fact that it is isolated.
Heavily.
Or insulated, yes, on the outside.
Jim Harvey making a tripartite telephone conversation, 2 phones.
And 1 mission director.
Indeed. DDO is now smiling. Perhaps that is an encouraging sign.
Yes. We're now coming up on 6 minutes into the launch window. If we were to start up now.
Well, we've still got plenty left, so no cause for alarm on that count.
In the picture right now, to your right, you have Don Cutina, the Executive Vice President of our customer Space Systems Loral, and to his left, we had the senior representative of their customer, NTT.
Tochikawa, the Executive Vice President of NTT.
Everybody anxiously awaiting the resolution of this problem.
Yes. Well, with the relatively unusual launch time, they're perhaps getting a bit anxious on their own account. They might be late for breakfast. And Mr. Chichika, the Ariane payload manager for Nstar B, he's really looking for information just as much as we are.
Yep.
Well, as we wait, well, the problem is obviously one concerning the satellite. I think it might be a moment to talk a little of the PARTA program, which is a quality support program for the Ariane launcher. And perhaps you could tell us how that functions, Rod, and along with it the component alert system for ensuring maximum quality on electronic components used in the launch,
Well,
which does, of
À
course,
12
sometimes
DDO,
overlap with satellite
la
messages.
reprise du temps des comptes devrait survenir d'ici 2-3 minutes, que tous les
just 1 minute.
moyens se tiennent prêts au redémarrage.
Simon, I have a phone call coming in here.
And we've got a call coming in into the cabin, and the DDO has just announced a likely restart in about 3 minutes' time. Perhaps we shall have some clarification from that on our phone call. Did we have some news there, Bud? Yes, we've had a further confirmation through our headsets that the count should restart in approximately 3 minutes from now. Which means that we shall have lost approximately 15 minutes of our nice, generous window.
Well, I'm back with you, Simon. I just had the confirmation that the count should restart in 2 to 3 minutes.
That is extremely good and encouraging news, but do we have any idea of what the problem was?
No, I'm sorry.
Suffice it to say that it has been, or is about to be, cleared.
That is indeed so.
Expressions perhaps a little less anguished than they were a few minutes back. And again, the two team leaders for NTT and Space Systems Loral.
And closest to the camera, we saw Mr. Pierre Gouja from Ariane Space.
Ariane still looks perfectly happy. Two members of the command cell, Charles Bigot and
Claude Kievre.
And you may have noticed once again in the launcher picture we had just now, the plume of vapor. And there we have it again, showing us once more that the trickle charging, so to speak, for the cryogenic propellants continues. In fact, until just before the arms open.
Mr. Samagas, the director of the operations division at Ariane Space.
The fact that we are on hold reduces the situation really to exactly what we have inside the synchronized sequence, in that it's merely a question of patience, wait and see. Is that not so?
Well, if the information we had a few minutes ago was correct, we should be imminently going into the count.
It is to be hoped.
It is not surprising if it takes a bit of time to verify the Nstar spacecraft. It is a very complex spacecraft.
Well, I think one can say that spacecraft or launcher, the issue is so great that any doubt at this stage of the count or at any time beforehand, one is not going to rush into a decision to, oh yes, it's all right, we can launch.
No, not at all. With a piece of equipment which you launch and for which you have no chance of getting your hands on for the next 10 years to come,
Ariane,
you
come back, come back, come back.
cannot take any chances.
No. A useful piece of equipment here in the large new Jupiter building.
Indeed, Simon. I think we have seen many of our guests tonight using that particular equipment.
Well, perhaps we can tell them we've got a pair of binoculars in here in the cabin as well.
Right.
And still that little bonfire out there beyond the foot of the launcher.
We are now 13 minutes past the hour, so we have used 16 minutes of our 2 hours launch window.
Plenty of time left, but I'm sure that everyone involved is thinking the sooner the better. We get started again. It's always curious in a situation like this. One sits and waits, and one gets more and more impatient perhaps, and then the count takes up again, and within a few seconds one has completely forgotten there's been a hold, and one is caught up in the anticipation and the excitement of the approaching time T0.
My colleague Masoud Zikr is surely informing our colleagues around the world what is happening down here. Mr. Coutinho impatiently waiting.
I wonder how much more he knows about it than we do. Quite a lot, I would think. I think we have some information coming in on our hotline telephone. We just saw Jim Walker obviously in contact with the spacecraft team in their ground control in the S1B building. So do you have something cogent to tell us?
Well, I just had the information that we should be looking at another approximately 3 minutes from now.
Okay.
À 12 DDO, la reprise du temps des comptes est prévue d'ici 2 minutes.
Right, we've just had an official announcement from the DDO quoting a figure of 2 minutes for restart.
Now this, of course, is exactly the reason why we do like to have a launch window of a certain length, such that you can have a small problem of any kind and resolve it and still not lose the opportunity to launch that particular night.
Indeed, and of course the length of the launch window for a particular flight, a particular mission, is entirely orbit dependent and can range from, to all intents and purposes, a make or break on-off window of a couple of minutes up to the 2 hours we have today, or even longer. The very short launch windows tend to be for the polar orbit launches.
Earth observation spacecraft in polar orbits, yes. Or scientific missions could also have a very short window.
And of course there's another phenomenon that we have from time to time, and that is a double window. 2 windows in the same night.
Yes, indeed.
Or in the same 24-hour period.
As a matter of fact, the previous flight, Flight 82, was the perfect example of that. We had a initial 15 minutes window followed by a much larger window some minutes later.
À 12 de DDO, reprise imminente du temps des comptes, que tous les moyens se tiennent prêts à un retour.
We've just had a further and even more encouraging announcement from the DDO. Restart of the count at time T0 minus 6 minutes is strictly imminent. It's a good thing neither of us are colourblind aboard, because we wouldn't know when we'd got back going again. And here we have got back going. The count has restarted.
À 12 de DDO, retour au vert de Nstar B. Attention pour le début de la séquence synchronisée. Top.
Sorry, in fact, I jumped the gun. We'd lost
Le
the
nouvel
rate, and we
H0
have now restarted the
est
count.
de 7
We are
heures,
into the synchronized
19
sequence,
minutes
and
et
may
38
we have an
secondes
explanation,
TU.
please, of what has changed in the command situation regarding launcher and satellite.
We actually had a perfect demonstration of the difference right now in the last few minutes, Simon, in all the events leading up to the start of the synchronized sequence. All the actions being performed in the countdown on the launcher are performed manually. That is, there is a person pushing a button or doing something, using his computers to monitor that everything is running well. From the minus 6 minutes mark and onwards, the situation is exactly the opposite. The computer is running the show, and the human is monitoring its correct execution. There are 2 computers doing this, one handling electrical tasks.
Just cut in for a moment, Bod. We have a close look at the cryogenic arms here. They're used to fuel the third stage with LOX and LH2. After gantry rollback and up to the last minutes of the count, these arms will open at T0 minus 5 seconds, and this establishes the initial condition for the ignition procedure.
Yes, so as I said, one computer is handling all the electrical tasks, and the other computer is handling all that which is to do with liquids flowing and gases.
Okay, so staying with LOX and LH2 for a moment, these propellants are transferred and stored at very low temperatures, and the fueling circuits and pipes must therefore be chilled down before stage 3 is fueled. And we must have a similar problem before stage 3 ignition in flight, obviously.
We are indeed looking at a strictly identical demand, yes. The chill down of the third stage propellant lines start just into the flight of the first stage, as a matter of fact.
Okay.
And continue all the way till the ignition of the third stage.
Fine. So what are the main physical events that we're going to see in the last minutes of the count?
Well, we're now at minus 3 minutes and 30 seconds, so the Nstar B spacecraft should now be on internal battery power. We will see exactly the same happening for the launch vehicle at minus 1 minute. At minus 7 seconds, the inertial navigation platform will be released, ready to guide the vehicle through its trajectory and onto its final orbit. And at T0 we will have ignition.
So in fact the signal from the ground computers to the table to open the clamps and thus release the launcher is the last command from the ground in the case of a normal flight.
In actual fact, there are two commands going at the same time. One to open the clamps and the other one to ignite the 4 solid boosters.
But after that, that's it. Ariane's on her own.
Yes.
But coming back to the command situation in the synchronized sequence, we're under computers, but is there still a human override capability? Say, for example, if a ground station went out?
Indeed so, yes. The human override is possible until the very last moments before the launch.
Not much. In fact, we're just down to 2 minutes to go, and the count has been running for over 14 hours now. And this is probably the moment to give our usual nudge to latecomers. You've just made it in time for Ariane's bus flight V083, carrying the Space Systems Loral-built Nstar B telecom satellite for NTT and NTT Docomo Japan. So please put down your glasses of milk for a few moments, please, and stay with us. And it's patience, wait and watch, and fight the tension, just like we were doing, all of us, through the hold. And this applies just as much in the Launch Control Center as here in Mission Control, does it not, Board?
Yes, now it's all down to waiting.
À 12 de TDO. Attention pour moins 1 minute. Top. H0 moins 1 minute.
And the wait will soon be over because we're into the final minute and the launcher is on onboard power.
There are now many events happening very rapidly as we near the moment of ignition.
The servo motors are armed and the inertial guidance platform will be released 1 second into the final voice count, and the arms will open at minus 5 seconds.
À tous de TDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage étape. Décollage. Pression pleine normale. Tout paramètre. Trajectoire normale.
Low cloud because we had that incredible fast start of the
Pilotage
44P.
normal.
And we lost the launcher almost immediately, though we are now tracking
Extraction d'étape.
on infrared from the cameras on Ile Bayol, just off the coast, opposite Kourou.
Indeed, so much for the clear skies that we had just a few moments ago.
It changes so quickly here. It's a piece of
Trajectoire normale et pilotage normal.
local feature. And we're now starting to get the announcements from the DDO confirming that all is well on board. 2 more relieved faces.
Just now we can hear the sound of the launcher passing over the mission control center here.
In fact, the building shakes here. Whether you can actually catch any sound of Ariane over our heads, Charles Picot looking a little more relaxed than a moment or two back. We're still on infrared tracking, and this will be taken up by the radar equipment initially here in Guyana, with the tracking stations in Kourou just down the road and Cayenne, and this will be taken up in due course by downrange stations in Natal, Ascension Island and Libreville.
We can see now, Simon, that we're 2 minutes into the flight and we're already moving at 0.7 kilometers per second and at an altitude of 32 kilometers.
Yes, well, it's a very fast start. And we have now on the screen the trajectory plot, which will be with us right through until final separation of the spacecraft. So I think it is the moment to explain how this functions, Bart.
Well, we're looking at 2 plots. One, a vertical track, the nominal flight path of the vehicle, and one horizontal track as it moves along the ground. As far as this vertical path is concerned, we see a elongated circle which is slowly climbing along that path. That represents the theoretical point where the launcher should be at any instant during the flight. Inside that circle there is a small cross which is barely visible on your screens, but it's there, and that cross actually represents the measured point where the launcher actually is, so its real position. And as long as, of course, as that cross is within the circle, we're doing very nicely, thank you.
And what you just said was just been confirmed again by the DDO. As we approach the second separation between the
Extinction L220. Séparation premier étage, allumage deuxième, tous paramètres normaux.
And we've just had in rapid succession burnout of stage 1.
Tous paramètres normaux.
Separation of the 2 stages and ignition of the second stage, and we just also had a computer-assisted replay.
On that curve now you will see a point called SEP-QUAF, which stands for separation of the payload fairing, which will be the next event coming up. Until that happens, we can maybe explain what all the numbers on the right-hand side of the screen means. Of course, T is the elapsed time since ignition. A is the altitude, now 104.5 kilometers, climbing rapidly. And V is the velocity, now at 3.2 kilometers per second.
And we're just coming up now to the fairing release and discard.
Séparation coiffe.
Now that is confirmed, and of course all the time since actual liftoff and to this moment of fairing release, we have been engaged in a venting process to equalize pressure inside the payload compartment and the outside atmosphere.
Indeed.
Altitude
of course,
120 km, tous paramètres normaux.
Fairing has until this point in time served as a protection for the spacecraft against the elements and against aerodynamic friction during the flight, the atmospheric flight. The fact that it has now been thrown away reflects that we're now outside the dense atmosphere. It's no longer needed. It weighs 800 kilos, so it's a dead weight which we do not want to carry any further.
We discard as soon as anything is no longer necessary. The whole objective is to reduce mass instantaneously.
Coming up on second, third stage separation.
Extinction L33. Allumage troisième étage, pression foyer normale.
And that is always extremely good news. ignition, clear separation as we see in the replay, and ignition of the cryogenic third stage motor.
The very same motor that will now be burning for
Paramètres
about
propulsifs normaux.
13 minutes, and as we said earlier in the transmission, it will provide practically half of the velocity that is imparted to the payload.
And in fact, as you say, we have a long burn time for the third stage and a rather more relaxed situation because the events come very, very fast
Tous paramètres normaux.
after each other during the first 6 minutes of flight.
Acquisition natale.
And we have further confirmation of everything in order on board, and we have acquisition of the first of the downrange stations at Natal in Brazil. Of course, we have an overlap. The spacecraft is still being tracked from Guyana, but now also by Natal. And I think this is the moment to examine the question of separation in a little more detail, Bod, because we've had 2 stage separations and the fairing. So perhaps we could look at this aspect of...
Well, as each stage burns out, it is being separated from what is destined to go on by a pyrotechnic cord. Braking rockets ensure that the separation of the spent stage happens a little bit faster than it would otherwise. And just before the stage that will go on ignites, there are a few acceleration rockets that ensure that the ignition occurs under some gravity, so some push, such that the propellants in the stage are well towards the bottom of the tank.
So in fact it is imparting a tiny acceleration.
It doesn't do anything for the total velocity, but it just ensures that there are no air bubbles in the
pulling the
propellants.
fuel back to the rear end of the
Indeed.
of the stage. Stage 1, stage 2, similar process.
Both of those two.
Tous paramètres normaux.
And the fairing, well, we've already described the pyrotechnic cord and the band release, so that is...
The fairing splits into two totally symmetrical halves and fall away from the launcher.
And all the discarded hardware, of course, drops into the ocean. And how can we be sure that it will sink when it gets there?
Well, as far as the first stage is concerned, there is again a destruction system that makes sure that it opens up,
Mission sauvegarde.
and aerodynamic forces during its fall down into the ocean makes it break up into pieces. As a matter of fact, the fairing, which is made out of a honeycomb material, can actually float, and it does float. We have actually had pieces of it turning up on the nearby islands, Martinique.
Well, a surprise for the fishermen. And what about warnings to shipping and aircraft with these bits and pieces dropping into the sea?
That is routinely being done before each launch, to make sure that we have no commercial aircraft or other aircraft that strays into the flight path of the vehicle.
And of course, satellite separation from the remaining part of the third stage is an entirely different process, and we'll describe that when we come to the appropriate time. Well, we've talked about the heavy launch manifest for 1996, and we must certainly not forget that we now are approaching the first qualification flight for Ariane 5, the future generation of the Ariane family, with flight 501 currently scheduled for early May. And a topical footnote, the Space Systems Loral Intelsat payload, which is due to go into orbit on the second qualification flight 502 later this year. In fact, it could be said, so let's say it, that the 501 launch campaign has already begun with the center core stage en route for Guyana.
Indeed, Simon. The launcher campaign proper will start here in Guyana by the end of this month.
And how long will this campaign last compared with a normal Ariane 4?
Well, naturally, being the first vehicle of a new type, it is much longer than our now very streamlined operations for Ariane 4. But as soon as Ariane 5 gets into a routine operation, we will be looking at the same time between flights, if not less.
Yeah. So this means that we're effectively entering the overlap phase, during which Ariane 5 will gradually take over from Ariane 4.
We shall be looking at parallel operation of the two vehicles through the year 1999.
So there can't be much doubt that we shall see two launches on their respective pads at the same time, just like in the early days of Ariane 4, and on more than one occasion in the next 2 or 3 years.
Indeed. And as a matter of fact, the operations on the two pads can be handled totally in parallel. We will need 3 to 4 days between an Ariane 4 and an Ariane 5 launch, purely in order to reconfigure the launch-based downrange stations and the on-site networks.
So the double launcher configuration on the ground is likely to become a fairly common sight. In particular, because we're also looking at an upsurge in launch services demand at the present time. And this looks like meaning two things in particular: a longer overlap period and a longer Ariane 4 production phase. In fact, another order for 10 more Ariane 4 launches has just been placed, I think.
Yes, I mean, I think what we're looking at is that our initial plans, which called for production of 104 Ariane 4s, turned out to be slightly optimistic in view of the demand for launch services. We're using them up faster than we thought. So that is indeed the reason why our management has taken the decision to order another batch of 10 vehicles. This in order to ensure that, as a matter of fact, that we do have sufficient Ariane 4s to launch for the overlap period.
Well, in fact, some recent figures I had was that the total number of launches is 130 so far ordered, and 86 Ariane 4 and the first 16 Ariane 5, and one wonders whether these will in fact be enough to launch the 70 or more satellites which it is planned to launch on Ariane between now and the year 2000.
Well, our market analysis says that they ought to be, at least in terms of the market share that we hold today. But as a matter of fact, the number of vehicles that we will produce until the year 2000 should allow us to even increase that share.
Well, the European space industry is clearly pulling out all the stops to meet this increase. Bigger workload, reduced production lead times, and greater productivity.
I think we've already seen that. Last year we launched 11 Ariane 4s, which is a record for our company. This year we're looking at the same number of launches, if all goes well. And indeed, for the later batches of Ariane 4s, we have been seeing reduced production times, reduced production costs, and indeed
perte de la station natale.
The goal for the Ariane 5 vehicle has all the time been to improve productivity.
So, talking of new orders, Arianespace has already signed 4 new launch contracts this year. Who are the customers?
Well, we have signed contracts with Egypt for the NileSat spacecraft. We have signed a contract for another Arabsat spacecraft for the Arab League. We have signed the Panamsat 7, and finally an INSAT 2E spacecraft for the Indian Space Research Organization.
Tout paramètre propulsif stable.
In that group of 4, Panamsat and
Trajectoire normale.
the Indian Space Research Organization, ISRO, are long-standing customers. In fact, who can forget the Panamsat launch on the very first Ariane 4 back in 1988?
Indeed, yes, I mean, it was a daytime launch, and it allowed our long-standing Panamsat customer to launch his business, as a matter of fact.
Well, for that matter, the relationship with Space Systems L'Oreal also goes back a long way, 1983, I think.
As a matter of fact, Space Systems Loral, or rather Ford Aerospace as they were called in those days,
Trajectoire normale.
were the first foreign
reste à peu près
spacecraft
3 minutes à
manufacturer to ever launch on the Ariane vehicle. We're talking about the Intelsat 5 series spacecraft, so Intelsat was the customer. Since then, we have launched nearly 20 spacecraft built by Ford Aerospace and later Space Systems Loral.
A very impressive figure.
They were, as a matter of fact, on Flight 7, so it was even before Ariane Space took over the commercial activity of the Ariane utilization.
And of course now we have NTT. The Nstar payloads certainly reflect the company's shift from state control, where the 3 earlier satellites were built by Nstar and provided by the Japanese government, to a privatized structure where they have been able to sign direct turnkey contracts with Space Systems Loral. The 2 new spacecraft will clearly contribute to NTT's ambitious aims in the area of multimedia and greatly enhance service spread and quality for its 60 million and growing subscriber portfolio. On the ground, NTT is switching fast from analog to digital networks, while pioneering the move towards optical fiber, placing particular emphasis on fiber to the home, or FTTH. The pace of NTT innovation is matched by the build time, only 2 years for the Nstar satellites.
All part of the strong Ariane partnership with its Japanese customers.
And we are now within just about 1 minute from shutdown of stage 3. A quick word here about 2 recent new appointments at Ariane Espace, those of Francis Avanzi as Chief Operating Officer and Executive Vice President, and Patrice Albrecht as Vice President, Communications and International Relations.
Il reste encore 1 minute de poussée.
We have 1 minute left of third stage thrust.
Well, as we approach this end of powered flight, perhaps we could explain why...
Acquisition Libreville.
And just cutting in there, we have acquisition of the launcher by the Libreville downrange station in Congo.
In Gabon, in Africa.
Yes, we're within a few seconds now of shutdown as opposed to burnout. This means that there is fuel left in the tanks of the third stage. Why?
We do carry a certain margin for...
Extinction 3e étage.
There we are. End of power flight.
And...
Yes, as I said, we are carrying a certain margin to take care of any variations in the parameters that are usually taken into account for the flight analysis. Margins that normally would not be used.
Right, so what is
Orientation en cours.
Procedure between shutdown and separation? We have a 3-minute period just about.
Now the third stage will reorient itself and the spacecraft to an attitude which has
Fin
been
de poursuite par ascension.
So Ascension just lost contact with the vehicle, which is normal. It will reorient to an attitude which has been requested to us by our customer, an attitude which assures that he will be able to make contact with the spacecraft as it comes up on the Perth ground station, part of the Intelsat network, which will be the first station to see the spacecraft. It should happen about 20 minutes or so after separation.
And talking of separation, I think we could just time to describe the procedure here, which, as we said earlier, is quite different from interstage separation.
It does not use the same technology as the interstage separations. The spacecraft is held onto the launch vehicle by a so-called
se déroule normalement.
clamp band, which holds 2 flanges together. That clamp band is cut, or rather the 2 bolts holding 2 halves together are cut with a pyrotechnic knife. And the spacecraft is separated with 8, in this case, 8 springs.
which just push it away.
Yes, well, it pushes it away and it pushes the third stage in the other direction.
Which, in a sense, could be considered as the start of the avoidance procedure.
You could say that. And that particular procedure is the set of maneuvers that the stage does after spacecraft separation to make sure that we have, one, no recontact with the spacecraft between the two bodies.
And we are now within 20 seconds or so of payload separation. Having travelled a distance over the ground of approximately 7,200 kilometers.
And now that we're into ballistic flight, you will see that the altitude is increasing rapidly whilst the velocity is decreasing.
Séparation Nstar V.
And we have big news of the separation of Nstar V. Enthusiastic applause here in mission control.
And a very content Jim Harvey, who has now, in the space of half a year, seen two of his spacecraft successfully.
Voilà, tout s'est bien passé, en dehors de ce petit rouge là, satellite, qui nous a retardé un petit quart d'heure.
All the bad memories of
Alors tout n'est pas terminé pour le lanceur.
hold that we
On va
had to go through
le
a little while
réorienter,
back
ce troisième
are
étage,
forgotten.
parce qu'il ne reste pas sur cette orbite de transfert géostationnaire. On ouvrira ces vannes des
Nstar V
réservoirs
has
pour
just
le faire
started
dégazer,
its independent
pour
life,
éviter qu'il explose.
and as you said, Lord, we have
Et ça sera
we
la fin de
expect
la
to
mission.
have acquisition.
Alors monsieur
Like
Charles
Perth.
Bigot va quitter le Saint des Saints pour venir parmi les invités et
about 25
prononcer bien
minutes
sûr
from
le
now.
petit discours de félicitations pour tout le monde, de satisfaction.
And the solar
Et
panels
puis
will
ce
open in
seront
3
les
hours.
clients
The
qui prendront
first
eux aussi la parole.
Average motor firing in 26 hours.
On a cette
And
Saint
after
Jupiter
that,
2, c'est une
Time to station.
manœuvre
testing.
qui est assez lente.
It will be about a week
Souterrain,
before the spacecraft is on station. And then a further 3 weeks of testing until the spacecraft is finally ready to be utilized by its end
In
customer.
service in a month, just about.
1.
Exactly.
Top.
That's quick.
Allumage d'étape. Décollage. Pression pleine normale. Fin de mission lanceur. 3, 2, 1, top. Allumage d'étape. Décollage. Pression pleine normale. Tout paramètre. 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage d'étape. Décollage. Pression pleine normale. Tout paramètre.
5 normal. Well, we have a
Allumage d'étape.
variety of this.
Fin décollage.
I think we can easily see on these images the rapidity of the liftoff of the 44P vehicles.
It's quite unlike any other of the Ariane 4 versions.
It's the GTI of the Ariane family.
The pictures you've just seen were in fact a mixture of the original shots that we
Des angles
saw
différents.
during this broadcast from the
C'était donc une
control center
Ariane
cameras
44P. Ce n'est pas la plus puissante, mais c'est la plus spectaculaire. Lorsque les 4 propulseurs d'appoint à poudre s'allument, ça fait un véritable éclair. Tout va bien donc pour Ariane, et techniquement et commercialement en effet, 4 contrats ont été signés par Ariane Espace depuis le début de l'année, ce qui constitue un record.
Effectivement, le contrat avec Matra Marconi Space pour le lancement du premier satellite égyptien de télévision directe Nelsat, avec ISRO, l'agence spatiale indienne pour le lancement de Insat 2E, c'est le 6e contrat passé avec l'Inde, puis Arabsat
We should now
2B
have
et
39
Panasat
spacecraft left to
7.
launch.
Il faut rajouter aussi qu'Ariane Espace a commandé 10 Ariane 4 supplémentaires à l'industrie spatiale européenne.
3.5 years.
Oh, yes,
3
something
years,
like that.
shall we
Yep.
say, yes. Well, of course, the job is almost finished for Ariane on this particular mission, but it's all starting again, or in fact
Au
it has
total,
already
130 Ariane,
started
dont
again. It never
86
stops,
Ariane 4
No, it
either on
doesn't.
the
Ariane
launch
5
pad
qui auront été
or
commandées à
in
l'Agence spatiale
the
européenne
satellite preparation
pour
buildings
servir la
or the
totalité
dock.
du marché international.
We are looking at conducting our next launch less
Voilà,
than a month from
Monsieur
now
Charles Bigot s'apprête
with the
That's
Intelsat
here we-
707 spacecraft.
à prendre
Here
le
we see
micro
Charles Bigot
et prononcer
congratulating
l'allocution.
the two senior representatives of Space Systems
Bien
Loral
sûr,
and
c'est forcé.
our operator customer NTT. And now, Donald.
From SSL and all on the SSL team, I would like to say congratulations to Mr. Bigot and to Mr. Tachikawa. For years, we have been trying to normalize space operations. This is about as normal a space operation as I have ever seen, totally unremarkable. And that's the way I would like to see him, and that is a remarkable part of it. I have never seen, and I've seen many, many years of space launches, I have never seen a more professional team than I have in my day and a half here in Kourou. The job is ours now for the next couple of weeks to get the satellite on orbit and to make sure it's checked out and operating correctly. And I'm sure that will happen, and NTT will have the payload that we contracted for and begin providing wonderful service to the people of Japan, and as it should be. And I want to thank you for having the confidence in us. Thank you again, Mr. Bigot, for just a wonderful, wonderful ride. That is better than United Airlines or Air France. It's just smoother. And good luck in the future. Thank you.
And Mr. Tachikawa of
I would like
NTT.
to say congratulations to everybody who worked for launching this satellite. I appreciate very much your effort to launch our Nstar on schedule, almost on schedule. First stage, I had some consciousness, but finally, you did very well. Originally, I was convinced Ariane Space and also SSL has been working good so that we will get a final success. So anyway, congratulations. Thank you very much, Mr. Bigot and General Kutina. Thank you very much, everybody.
Well, friends, here in Guyana, it's coming up to breakfast time, and the show for flight V083 is just about over. We hope you enjoyed it. It's been our pleasure to have you with us. So let's meet again soon, say on 1st, 2nd March for flight V84 with the Intelsat 7 payload riding high on an Ariane 44LP. So this is goodbye for now from
me, Bård Eilertsen. Goodbye.
I like that pronunciation. And Simon Hayes. Goodbye.
Bye-bye.